let's say we have a hypothetical reaction wherein you have a reactant A forming your product P. Now, what I would like to determine or express mathematically is the differential rate law expression. So, if the order of the reaction is zero order, we can express that the rate R is equal to the change in the concentration of A with respect to T, which is just equal to the rate constant K because zero order yung ating reaction. Now, if we have a first order reaction, the rate will be equal to, again, it's the change in concentration of A with respect to T, but this time, it's K times the concentration of A. And finally, if we have the case for a second order reaction, it's again the change in the concentration of A with respect to T, and this is now equal to K concentration of A squared. Kasi nga, second order yung reaction natin. So what we found here, or what we have expressed here mathematically, is some kind of differential equation that we can later on integrate to come up with what we call integrated rate laws. So yung integrated rate laws natin, ito yung mga equations kung saan ibibigay sa atin yung concentration at any time t, and also sometimes we can calculate or determine the rate constant. In other words, using this integrated rate laws, we can express mathematically yung ating concentration profiles. So if we solve this differential equations, what will be the resulting expression for the rate law? So what you will obtain is something like this. For the first, or for the zero order reaction, the concentration of A will be equal to the initial concentration of A minus the rate constant times T. For first order reaction, you'll have concentration of A equals the initial concentration of A times E raised to negative KT. Or you can express this in log form. That's ln of A, or rather ln of the concentration of A, is equal to ln of the initial concentration of A minus Kp. And lastly, for a second order reaction, you'll have 1 over the concentration of A will be equal to 1 over the initial concentration of A plus Kt. So you can simply derive these equations by just solving the differential equation, or solving or integrating the differential rate law. So please try that. Next, let's say gusto nating malaman yung rate constant. So ang gagawin natin is you can actually obtain that by plotting the necessary variables. Now the question is, for each of these types or orders of the reaction, ano dapat yung ipa-plot natin to obtain a straight line? So for a zero order reaction, all you have to do is just take a look at the integrated rate law. So it looks like we are plotting what? Time in your x-axis versus the concentration. In your first order, we have time pa rin, right? But this time versus ln of the concentration. And for the second order reaction, it's time in your x-axis versus the reciprocal of the concentration. So by doing these plots, you will be able to get the slope and the y-intercept. Okay, and the slope will correspond to the rate constant. So just to write what I've just said, for a zero order reaction, ang magiging slope natin, if you did the previous plot, you will obtain negative K, and the y-intercept is the initial concentration. For the first order reaction, the slope will be equivalent to minus K as well, and the y-intercept is ln of the initial concentration. And finally, for the second order reaction, the slope will be equivalent to K, and the y-intercept is just the reciprocal of the initial concentration. Next, it's also important to affix the correct unit for the rate constant K. So, paano nga ba natin malalaman yung correct na unit for K? For a zero-order reaction, okay, rate, again, just to write what I've written above, is equal to K. Alright? And if you have a unit for R, which is something like moles per cubic decimeter second, if it's a zero-order reaction, then therefore, it will have the same, or the K value or the rate constant will have the same unit as the unit for the rate. So therefore, I'll put here that the rate, or rather the rate constant unit that we'll be using for a zero-order reaction is equal to, or it's expressed as moles per cubic meter per second. Of course, you can use other unit for the amount of substance aside from moles, or you can use another unit for time and also for volume, but the overall structure or the overall appearance of the unit will be the same. What if you have a first order reaction? So it's expressed as R equals K times the concentration of A. So if the rate is expressed in terms of moles per cubic decimeter per second, and the concentration is in terms of moles per cubic decimeter, then it will soon be revealed that K will have a unit of inverse second. And similarly, you will be able to obtain the unit for K for a second order reaction, and that will be cubic decimeter per mole second. And finally, we want to obtain an expression for the half-life. So basically, yung half-life, ang ibig sabihin nun, it's the time kung saan yung initial concentration mo ay nangalahati na. Okay? For a zero-order reaction, the half-life, and let's use the symbol T1 half. For the zero-order reaction, it's the initial concentration divided by the twice the value of the rate constant. Now, for the first order reaction and karaniwan sa mga, let's say, radioactive decay and many other processes, okay, they follow first order reaction kasi. So, you will have the expression, or you will use this expression ln of 2 divided by K. And lastly, for a second order reaction, that would be equal to 1 over K times the initial concentration. Next, let's consider second order reactions. Second order reactions, and we actually have identified or expressed the integrated rate law for a second order reaction. So we have put it in the table, okay, which is right here. However, remember that the reaction that we dealt with here is A forming P. Now, what if we have the case for, we have, let's say, A. So, A plus B forming P. And then we found out that this reaction is first order in A, first order in B, and therefore second order overall. So, ibig sabihin, the rate law is expressed as K times the concentration of A squared times the concentration of B. Oh, sorry, the concentration of A should be raised to 1, and then the concentration of B should be raised to 1. So, paano kapag ganyan yung ating rate law? In other words, the situation is that we have second order reaction but with multiple reactants, unlike what we have in the table above. So, we can divide this problem into two situations. Number one, the first situation is that we can have the concentration initial of A equivalent to the initial concentration of B. So if this is the case, the integrated rate law will be ln of the concentration of B times the initial concentration of A divided by the concentration of A times the initial concentration of B equals K times the concentration of B initially minus the concentration of A initially times T. I'm sorry, this case should be that the initial concentrations are not equivalent. Or you can express it as ln of the concentration of A over the concentration of B equals K times the initial concentration of A minus the initial concentration of B times T plus ln of the initial concentration of A over the initial concentration of B. So either of these two equations can be used. Now the second situation is yung sinabi ko kanina wherein the concentrations of A and B are equivalent. So paano kapag ganyan? Okay, so in this case, you can actually find that this will just reduce to 1 over the concentration of A equals 1 over the initial concentration of A plus KT, which was our original case na nakalagay dun sa table. And lastly, if you have a case of a series or a parallel reaction, then you can find in this table shown yung mga iba't ibang integrated rate laws nung ating reactions, which we also call concentration profiles.